Good morning, students. Today my discussion on limit, which is the one part of calculus, and my discussion on limit, definition of limit, and epsilon delta technique, and definition of limit also. First, what is limit? First discussion, what is limit? Let us consider an example. Suppose Cuttack is city, another city is Bhubaneswar. Just you see, the distance between Cuttack and Bhubaneswar approximate to 25 km. Approximate to 25 km. The approximate 20 km means it is not equal to 20 kilometers, not equal to 25 kilometers. That means it may be 25.02 or 24.9. In this type of case, the distance limit between Cuttack to Bhubaneswar is equal to 25 kilometers. Similarly, let us consider an example. What is my example? Just you see, suppose I have a function f of x is equal to 3x plus 4. F of x is equal to 3x plus 4. If we put x is equal to 1, automatically f of 1 is equal to 3 into 1 plus 4 is equal to what? 7. That means this 7 is equal to y. That means f of x is equal to what? Y. When x is equal to 1, automatically f of 1 or y is equal to 7. Let us take this example. If x is close to 1, y also close to 7. Okay, suppose we take one more example. Suppose x is equal to 2. So what about f of 2? F of 2 is equal to 3 into 2 plus 4 is equal to what? 10. That means when x is equal to 2, automatically y is equal to 10. This is also x is close to 2, y is equal to close to 10. In the first case, x is close to 1, y is equal to close to 7. That is close to. Suppose if we put x is equal to 1.1, this is my case 1. If x is equal to 1.1, what about y? Y is equal to 3 into 1.1 plus what? Plus 4 is equal to what? 3.3 plus 4, that means 7.3. Okay, that means x is equal to 1.1, then y is equal to 7.3. If x is equal to 0.9, then what about y? Y is equal to 3 into 0.9 plus 4 is equal to 2.7 plus 4 is equal to what? 6.7. That means x is equal to 0.9, y is equal to 6.7. Just you see, when x is equal to 1.1, y is equal to 7.3. When x is equal to 0.9, y is equal to 6.7. This is my case 2. From case 1, x is close to 1, y is close to 7. If x is close to 2, y is equal to close to 10. Similarly, when in case 2, x is 1.1, y is equal to 7.3. When x is equal to 0.9, y is equal to 6.9. In case 1, x is close to close, but in case 2, x is closer to closer 1 or x is equal to closer to closer 1, then y is closer to closer 7, or x is nearer to nearer 1, y is also nearer to near 7. In case 2, we are defining limit is a concept of closer to closer or nearer to nearer, not it is closed. That means this concept of limit is derived in case of a nearer to nearer or closer to closer. As per the second example, as per my second example, means when x is close to 1, when x is close to 1, y is equal to close to 7. When x is equal to close to 1, or when x is equal to closer to 1, then y is also closer to 7. X is closer to 1, y also closer to 7. This closer to 1, that means x is not equal to 1 and y also not equal to 7. For this example, we derive x is equal to 1.1, y is equal to 7.3, x is equal to 0.9, y is equal to 6.7. This type of presentation is expressing x tends to 1, y tends to 7, or this symbol is known as tends to. That means that is not equal. Tends to means not equal to. That means not equal to, or it is tends to, or what is that? Approaches to. For the second example, we suggested that limit is a function closer to closer or nearer to nearer. Again, limit is a real valued function. If a question is coming, what is limit? Limit is a real valued function. Limit is a real valued function. Just an example, why limit as a real valued functions? Here, from example 2, limit x tends to 1, 3x plus 4 is equal to 7. 3x plus 4 is equal to 7. What is the meaning? That means x tends to 1, 3x plus 4 is equal to what? 7. This 7 belongs to real number. It is a function, and this function is a polynomial function, and this is a approaching value. What is that? Approaching value. Just you see, when x tends to 1 means x not equal to 1. That means x is closer to 1. That means x may be 0.9 or x may be 1.1. X may be 0.1. Similarly, this 7 is not equal to 7, but it may be 6.7 or it may be 7.3, whatever may be, but it is not equal to 7. Here we define limit is a real value function, means the value which is coming after putting the approaching value to the function, that value is a real value, or that value belongs to a real number. That is why it is a limit is a real valued function. Okay, that means x tends to 1, x approaches to 1, 3x plus 4 is a function. Limit is a function. That function may be a polynomial function, that function may be a trigonometric function, that function may be a logarithmic function, that function may be an exponential function. What functions that given a real value. Just you see, what is the definition of a limit? I already told everyone, limit is a function, and the value is coming of a limit is a real value. What is the definition of a limit? Just you see, limit x tends to a, f of x is equal to L. Limit x tends to a, f of x is equal to L. That means L is the limiting value, f of is the function, x tends to a means that it is an approaching function. That means epsilon greater than 0, delta greater than 0, delta depends on delta depends on epsilon such that how we can define the limit? Just you see, limit x tends to a, f of x is equal to L, where epsilon greater than 0, delta greater than 0, and delta depends upon epsilon such that, just you see, x minus a modulus is less than delta, double implies f of x minus L modulus less than epsilon. That means this is the definition of the limit. This is the definition of the limit. That means a limit is defined when f of x is equal to L, where x approaches to a. That means epsilon is a small quantity, delta also small quantity, epsilon greater than 0, delta greater than 0, and delta depends upon epsilon such that x tends to a, that means x difference a modulus less than delta, double implies f of x minus L modulus less than epsilon. What is that? That is the definition of a limit. Again, we also generalize this concept. What we? That is x is less of a plus delta, x is greater of a minus delta. Again, it is double implies f of x is less of L plus epsilon is greater of L minus epsilon. Again, also we generalize the limit function. We also generalize limit function. Just you see here, f of x is equal to function, or it is limit function. F of x is a function or limit function. L is equal to limiting value. How we are getting the limiting value? We putting the approaching value to the function. Then what result is coming? That is L. That L is known as limiting value. X tends to a means it is approaching value. I already told everyone limit is a real valued function. What value of L is coming? It is a real number. Function, different type of function. Either it is a polynomial function, either it is an exponential function, either it is a trigonometric function. Whatever the functions, the after solution we are getting a limit is a real value. This is my definition of a limit. Just you see what way we are getting the value of a function, or what way we are defining a function. Just you see. Let us start. Just you see. Suppose limit x tends to 5, x plus 5 is equal to what? Just you see, it is a polynomial function. Limit is a function, it is a polynomial function. X tends to 5, this means approaching function is 5. This type of a function, you directly put the approaching value to the polynomial function. Then 5 plus 5 is equal to what? 10. That means limit x tends to 5, x plus 5 is equal to what, beta? 10. It is example 1. It is my example 1. Similarly, I proceed with the example 2. Limit x tends to 5, s square plus 5 by x plus 9. What is the value? Just you see. It is also polynomial function. What is the limiting value? You put directly value to the here. 5 square plus 5 by 5 plus 9. It is what? 25 plus 5 by 14. So 30 by 14 is also belongs to a real number. Because limit is a real valued function. Here also belongs to a real number. Limit is a function. Means a function has a domain, a function has also range. If it is a polynomial function, this function has a domain, has also range. The value automatically it is coming 10. 10 is the range value. Similarly, range value is 30 by 40. After putting the approaching value, here also after putting the value, we are getting the 10. Okay, teach. Okay, dear students. Now, this is my example 2. Then we proceed with the example 3. Just all of you, right or not? Okay. Then again we proceed to example 3. Just you see example 3. In example 3, just you write limit x tends to 2 s square minus 4 by x minus 2. X minus 2. What is the limiting value? As per my technique, you put the value to the variables and we put here 2 the square minus 4 by 2 minus 2. So what is that? 4 minus 4 by 2 minus 2. What is that? 0 by 0. This is undefined. This is undefined. If we are getting this type of a value 0 by 0 or infinity by infinity, when we put the approaching value, this type of result is an undefined concept. Because if it is undefined, that is not under a real number. I already told to you, limit is a real value function. That is why the result should be a real number. But 0 by 0, infinity by infinity is not a real number, or it is undefined. If it is undefined, so it is not satisfying the concept of a function. If we satisfy a concept of function, the function has a domain value, the function has range value. But this function has domain value, but the range value are not defined. So, if we are getting this type of a question, we have to balance the question first. We balance the question first. What is my balance? Just you see, first we balance this question. X tends to 2, s square minus 4 by x minus 2. How can balance? Either we are using different limiting formula, otherwise we are focusing different type of algebraic formula. If we balance this question, what shall we do? X tends to 2, we go for the formula of x square, 2 the square by x minus 2. Just you see, what is that? Limit x tends to 2, x plus 2 into x minus 2 whole divided by what? X minus 2. X minus 2, x minus 2 cancel. So what do we get? Limit x tends to 2, x plus 2. Just you see. That means we balance the function, by using the algebraic formula. After using the algebraic formula, the function are generalized. What is the function value? X plus 2. That means it is an existing function. This existing function has a domain value as well as range value. That again we can directly apply the value 2 plus 2 is equal to 4. So what is my concept? Limit x tends to 2, s square minus 4 by x minus 2 is equal to what? 4. Is equal to what? 4. In first case, it is undefined. In second case, it is defined. That means this case is the correct case, but this case is not the correct case. Here, 0 by 0 is undefined. Otherwise, if it is coming infinity by infinity, it is also undefined. But this case or case are the correct one, because R is belongs to 4 is belongs to R. That means limit is a real valued function. Right or not? If you are getting this type of questions 0 by 0 or infinite by infinite, we always balance the function. Then after we are getting the value of limit. Otherwise, we are not getting the value of limit. So, people, either you are using any limiting formula, otherwise algebraic formula, then you can solve the problem. Let us start one more question again. Let us take one more question. What is the question? How to find the limit? How to find the limit? Just you see, first we put the approaching value to the limiting function. Then we get the value of limit. This is first. What about my second? If limiting function given 0 by 0, infinite by infinite, 0 to the power infinite, then this is undefined. This is undefined. In this case, we use algebraic formula and limiting formula for justifying the limiting function. Clear? What is the way we are getting the value of a limit? First, we put the approaching value to the limiting function, then we get the value of a limit. Otherwise, when we putting that value, we get 0 by 0 or infinite by infinite. We balance the undefined concept, and by using of algebraic formula and limiting formula, by that we are getting the value of a limit, because limit is a real valued function. I already clarified 2 to 3 example in what way we put the value to the limit. Is it okay? That is what this is the fundamental definition of a limit. Now limit related to epsilon delta technique. Now we discuss about epsilon delta technique. Epsilon delta technique. Epsilon delta technique. I already told you what is the definition of a limit. Just you so let limit extends to a f of x is equal to what? L. Limit extends to a f of x is equal to L. Epsilon greater than 0, delta greater than 0, such that x minus a modulus less than delta, double implies f of x minus a modulus is less than epsilon. This is what? This is the definition of a limit. Here, the role of a delta and role of a epsilon in other way known as epsilon delta technique. Other way known as epsilon delta technique. For an example, that means we justify this part to this part, otherwise we justify this part to this part. This is the definition of a limit. For example, limit x tends to 5 s square plus 5. Now I want to define this value by using epsilon delta technique. First, we should find the here limiting function is defined, but limiting value is not here. First, our duty is finding the limiting value. How? We can put direct value here, 5 square plus 5, which is equal to 25 plus 5 is equal to 30. That means limit x tends to 5 s square plus 5 is equal to what? 30. Now this limit is a complete one because it has a limiting function, it has a limiting value, and it has approaching value. Now we justify by epsilon delta technique. Just you see how can justify by using epsilon delta technique. Just you see what way. We first define limit x tends to 5 s square plus 5 is equal to 30, comma, epsilon greater than 0, delta greater than 0, delta depends on epsilon such that x minus 5 modulus less than delta, double implies f of x. What is f of x? S square plus 5 minus 30 modulus is less than epsilon. First we should be taken this part, then we prove this part. Just you take limit x. What is that? We take the right part, s square plus 5 minus 5 minus 30 means what? S square minus 25 rho modulus less than epsilon. Again we can justify x rho square minus 5 rho square rho modulus less than epsilon. Then we justify x plus 5 into x minus 5 rho modulus less than epsilon. Again we justify x plus 5 rho modulus is less than epsilon, comma x minus 5 rho modulus is less than epsilon. But what is my requirement? My requirement is x minus 5 less than delta. We take here x minus 5 rho modulus is less than epsilon. Here we may choose epsilon is equal to delta. That's why we put x minus 5 rho modulus is less than delta. Is less than delta. Okay, we take this part and prove this part. Here, what is the relation between epsilon and delta? Epsilon is equal to delta. This is the way to defining epsilon delta technique of a limit. Today, I may cover what is limit, what is the definition of limit, and how a limit is described by using the epsilon delta technique. Thank you very much.